Ever written a piece of code that you thought it was perfect until someone else tried to use it? Let's look at this simple Python code. All it does is ask for your age, and then it will convert the string to a number. Now, if we run the code, Python will show us this message which comes from our input. Now we're asking the user how old they are, and let's say the user will type in 21. Now, this is fine. This will work because Python knows in this second line how to convert this 21 text to a number. But what if the user types the number out as a word? What happens now? Well, our program will crash with this scary looking value error. And the reason is because Python cannot, in this line, cannot convert the word 21 to a number. So how can we make our code to be resilient to what the user types in? To stop our program from crashing, we need to give it a safety net. In Python, this safety net is called a try and except block. So remember, this line of code was making our program to crash if the user entered words such as 21. What we can do is we can put this line, let's call it the risky code, the code that might crash. We put this line of code inside a try, and then we add an except block to catch the error and decide what to do instead of crashing. So we put our risky code inside the try, and if this code fails, instead of crashing using this except key, if we have value error in this block, in the try block, Python then will run our alternative, let's call plan B. Using try and except is like saying to Python, hey, give this a try. If the code inside the try block works, great, no problems. But if it doesn't, don't explode, just handle it nicely. And here in the except block, we're giving an alternative code that Python should run instead of crashing. So let's look at our new code that is ready for anything that the user throws at it. So this is the new code now. We see that we have put the line that was dangerous or the risky code that might crash. We put it inside this try block. And in the exception block, we're just asking the user to please use digits instead of words, basically. So our program this time will not crash if the user enters words. Now let's run that problematic scenario again. So if the user enters 21, this time our program will not crash, and instead it will print out this message to the user, and then the user knows that it should enter digits and not words. All right, enough with theory. Let's see this in practice. So I'm going to use the input function to get the age of the user. How old are you? And then I will save this in the variable age. But this variable, as mentioned in video 5, this is a string and not a number. So we need to convert it to integer. So I will do int age, but just to show you that it is string, I will also print the type of age before conversion. And let's also just add some code. Let's say you will be, I'm gonna use f string so that I can use the variables and do this plus operation. It will be next year. All right. So let's say this is our code. Now, if we run this, now Python stops in this first line, and we get this question, how old are you? Now, we will enter 21, hit enter, and we see that the code continues running. So we get this print here first. We see that it is of type string indeed, this age, even though we entered 21 as a number in digits. And in this line, we should get it back to integer, our variable. And we see our print here, you will be 22 next year. Everything works fine. If we enter a digit. Now what happens? Let's rerun this. Again, how old are you? Now this time I will enter 21 as in words and hit enter. And we see that we get an error, the value error, Python telling us which line we got the error, which is quite nice. So we get an error in this line. And the reason is that Python cannot, this int function cannot convert the word 21 to a number. So let's try to fix this with our try and except statement. So let's do this. I'm gonna copy this whole code and I'm gonna paste it here. So the risky line that may crash depending on the user input is this line where we convert the age to an integer. So what we should do is we should put it inside the try block. So we're telling Python, try this line, except if you get this value error. And inside the exception block, we can ask the user to enter a valid number. This time, again, using the int, we can say, please enter your age again as a valid digit number. All right. And then we have our last line of code. So let's run this. First, I will just give it 21 as a digit. This should work as expected. Yes, same as before. Now I will rerun this. This time I will give the word 21 and hit enter. And let's see what happens. And we see that first we have this print, which comes from second line of our code, which shows that the variable age has type string. Now Python has stopped here because there was a value error in this line. So Python entered this exception block. And here we can see here it's asking us, please enter your age again as a valid digit number. So this time I'm going to put 21 and enter, and it will continue. Well, I got an error because I forgot to convert the age to integer. So let's do this. Let's rerun this. So let's say first time we give it 21. And again, the first print, and Python is asking us, so we are in this line of code. Python has stopped and asking us to basically enter a valid digit number. So if we do 21 this time and enter, the code will work. We will get 21. This line will convert it to an integer, and this plus operation here will work this time. All right, all good. I want to mention one more thing. I'm just gonna copy the whole block. So in this code, we're catching only value errors. So if you have more code in your try block and other types of errors happen, your Python code will still crash. But that could be an intended behavior maybe. But if you want to catch all the errors, so if you say whatever error happens in my try block, I want to run the same code in the except, then you can remove this specific error, type of error, and leave it empty. Now, basically any type of error that happens here, you will enter this. So let me put an error. Let me say, do an illegal operation. For example, let's say hello +1. This is an illegal operation because I'm using the plus operation with a string and an integer, which will give me a type error. But since we have no specific error, all the errors that happen here, we will end up here. Now let's run the code. And I'm gonna give even a valid number just to show you that we will still enter this exception block because of this second line that we have, which is an illegal operation. So I hit enter, and we see that we entered this except block because I see here, please enter your age again as a valid digit number, even though we did enter a valid number. But because our code has a bug, this second line, we are coming here all the time. Well, in this case, yeah, we came here and we had to re-enter it. So basically, if we remove the specific exception or type of error, whatever error happens here, value error, type error, or any sort of error, we will run the code in the exception block. Of course, this is quite risky, and I don't recommend using try and except in this way. A good practice here is to basically catch the error that you anticipate that might happen. So we remove this and we only catch the value error. And only if we have a value error we have. So if, let me put it back, the illegal command, hello +1. And if I run this, I will get an error. So let's enter 21. This time our program crashes and it says, yeah, can only concatenate a string to string. But this is a good thing. So this crash is a good thing because this is an actual bug in our code. And to fix it, we need to basically make this also a string. And now our code will work this time. 21. And there we go. Our code works again. So as a summary, when we have some code that might crash due to things that are out of our control, such as this user input, then it's a good idea to put that risky code inside a try block and then catch the error, the expected error, and then have an alternative code that our code still runs. But remember that if you remove the specific type of error, whatever error that happens in the try block, Python will run the except block. So it is highly recommended that only, first of all, only put the part of your code that you anticipate that you might have error inside the try. So don't put all of your code inside the try. Then you don't know from where the error comes. Only put the actual line of code that you think there might be problems, and only catch the error that you expect. All right, I hope all of this makes a little bit more sense to you now than before watching the video, and see you in the next video.